Welcome back to the 6th Gear Garage. Today we have a laser welder. This is the XLaserLab X1 Pro, and it does more than just laser weld. It's also a laser cutter and a laser cleaner. 3-in-1, and we're gonna test it out. Okay, quick disclaimer, I am not good at laser welding, as I found out. A lot of these videos out there make this seem a lot easier than it actually is, and well, you'll see what I mean later on in the video. First, let's take a look at everything that comes in the box. Here is the X1 Pro itself, and right off the bat, I love the design of this thing. I'm an old Apple fan, and this looks like a modern rendition of the PowerMac G5 towers, which have a timeless design. We have plenty of cooling, as well as all the connections on the back to keep things looking clean. There's an integrated handle on the top, making the unit easy to transport. A large touchscreen, safety controls on the front, and over here we have the actual gun. And this also looks like something straight out of the future. The craftsmanship and design of this whole unit is impressive. Looks absolutely top-notch. We also have a grounding clamp, a remote emergency shutoff, in case you're not close to the machine. Here we have a couple of extra focusing lenses. Here's what that looks like. And here is the power cable. This unit runs on a 20 amp, 120 volt outlet. There's where it connects to the machine. And over here we have the wire feeder. This will be used in some welding applications. There's a look inside. And here is the signal cable for the wire feeder. This goes from the back of the welder to the wire feeder. And this is the actual cable for the wire itself, going from the wire feeder to the gun. Here we have some wrenches and different size tips. In this box of parts, we have a wire feed wheel, and these are all extra protective lenses for the laser head. In this metal case, we have a variety of different nozzles, and depending on the application, we have a cutting nozzle, a cleaning nozzle, and different welding nozzles. And a second case over here. Most of these look like duplicates. So they give you plenty of spare consumables. They also include the safety glasses. And here's how things are gonna look through those. And XLaserLabs also supplies a physical paper owner's manual. No PDF you have to download and read on your phone. And this is a thorough manual. Plenty of color photos and screenshots of the menus. I've read through this, and it's actually very well written. They give you everything you need, plus some extras. Let's set it all up. The first thing I had to do was swap out my old 15 amp outlet to this 20 amp outlet. And that's because the X1 Pro uses a 20 amp plug. Everything is still 120 volt with 12-2 wiring, so there's no major wiring to do here. Just a simple outlet swap, which takes less than 5 minutes. And here's the plug for the emergency stop button. That goes here. And down here we have the cable for the wire feeder. And it screws on to tighten. And this one's for the power cord. That ain't going nowhere. And down here is the gas fitting. And this line just pushes in and locks. And here's the gas line. This is 6 by 4 millimeter. 6 millimeter outside diameter, 4 millimeter inside diameter. And all this came in this kit I got on Amazon. It has all these push fittings and these brass ones, which are actually what I needed. Some Teflon tape. It was under 20 bucks. I'll put a link in the description. Now, I have two options. First, I made this to use for cutting and cleaning. And this way, I can use dry compressed air from my air compressor over there. For cutting and cleaning, clean, dry, compressed air is gonna be fine. So that way, I'm not constantly using up shielding gas, because I only really need the gas for welding. I had a hard time finding an adapter to connect that 6 millimeter line to my regulator. No welding stores around had anything. So I bought this online, and it's a little too small. So I scrounged around and found some pieces and parts that'll do the job. It might not be pretty, but it should work. Don't get pulled over with this in your pocket. Officer, I promise, it's just for a gas line. Now for the wire cable. This end goes in here. Then tighten down the set screw. Actually, pop this open here. We'll move this back out just a tad. I already had a spool of 0.8mm wire, so we'll use this. First, I need to switch to the appropriate size rollers, and these just unscrew. So these are 1.2 and 1.6, and they included a 1.0, which is also 0.8 on the other side, which is what I need, but there's only one. So I guess we'll run one and see how it goes. I'll just throw this one back on to look good, I guess. And I'm not sure what this other bolt's for. And you go on there. I like this quick release. And back here, I need to connect the signal cable. And we'll run this through here. Oh, hold on a minute. I think I just found the other roller for the smaller wire. Yep. All right, we'll install that in a second. And look at that bolt that was holding it in. Look familiar? So that's cool. You can store the extra rollers right here in the back. Swap this other roller out now. And you go there. And get this started in here. And we're ready for power. Oh man, this is gonna take a while. Let's check out this gun situation. So the cable for the wire feeder is going to go through here like this. So let's take this off. Going to have to take a tip off first. And this nut and a washer. Now this mounts here. On goes the washer, then the nut, then this one, and the tip. So now the wire lines up in those little grooves on the nozzle. Just like that. And out and in. Another tip I found. If you want to load the wire a lot faster, you can just change the wire speed right here. Look at that. Now that I have the gas fittings figured out and the wire feeder sorted out, we can finally plug in the grounding clamp here and we are ready to weld. Now I'm going to show you how all three modes work. First, we'll try cleaning, and then cutting, and then welding. And then after that, I'll talk about all the features and benefits and the potential drawbacks of this setup. So we're looking for the AS20D, which is for cleaning. And there it is. So I have some thinner pieces of metal that's been painted, something a little bit thicker, also painted. We have some bare steel with some surface rust on it. So we're gonna go into cleaning mode, confirm. And this is the default settings. We have adjustable power, frequency, duty cycle, and width of the cleaning beam. And one more thing to show you real quick, if you go into set, there's a monitoring system, and it'll give you a sort of a checklist of all different things that need to be operational in order for this to start working. You see there's also a check for air pressure. If I disconnect the air, you can see that turns red and it won't let you use it without air pressure or gas or welding. Hook that back up and now you can hear that it has air. You'll see there's a red alarm light on up here, and that's just because we're not ready to go because we haven't turned on the key to activate the laser yet. Now we're good. And so I'm going to clean this piece first here, and you're supposed to use the grounding clamp on here, and then that way, when the tip of the gun touches this and you're dragging along, you complete the circuit. But I found that sometimes this just works better if you sort of cheat and just clamp it on the gun itself. Of course, the only disadvantage is now you can laser clean anything, not just the source of what you're working on. But especially if you're working on something that's painted or pretty rusty, then this may not work on the surface. And once we connect the ground clamp, you can see the last step is just the gun trigger. And that's not going to work until we push this button right here and confirm that we are ready to use a class 4 laser. One benefit is that there's not a lot of like spatter or hot metal flying around, so you don't need these really thick welding gloves. I can just use some more comfortable, much thinner regular work gloves. Glass is on. Push this one more time and it'll turn green. Now we're ready. And it's that simple. And this is at 50% power. So it does make a bit of a charred mess if you clean metal that has paint on it. I bumped the frequency up to 2500 hertz. Let's see what happens. Pretty much the same thing. Let's try 50 hertz. I can't tell much of a difference in the hertz settings in this application. I think the lower hertz might have come out a little bit cleaner there toward the bottom. Something small and precise like this would be great for cleaning old rusty tools. And it's fairly warm to the touch. Notice the etching marks. I'm going to try a higher frequency and see if we can eliminate those. Yeah, just like with my continuous wave laser cleaning machine, the higher frequency will leave you less of these etching marks behind in the surface. And again, it's barely warm. Here's an old rusty steel rim that I used in a previous laser cleaning video. Really thick, crusty, scaly, Northern Ohio rust. And that did an excellent job. I'm going to go a little faster this time. Let's try 100% power. So I can go pretty fast, and pretty much all the flakes and scaling was blasted off, except for that one spot right there, which was toward the end, and it's probably as I was pulling away to start another pass. You know, initially I thought, who's going to use an 8mm wide beam to clean a large object? But if you don't have a dedicated laser cleaner, this thing honestly works pretty well. So while it would take a lot longer to clean a large object like this rim than it would with a dedicated cleaning machine, you could definitely do it. I didn't think I'd be very impressed with the cleaning capabilities of the machine because I have dedicated laser cleaners. But as we found out, it can remove very heavy rust. And also, being a 3-in-1, it's good to remove rust from metal right before you go back and weld it. And where the advantage is that this machine is portable. I can take it to any 120 volt, 20 amp outlet. Whereas my laser cleaning machines, they're way more than I do, and they're not exactly portable, requiring 220 volt power. Now let's go try the cutting. It's important to note that you can't point this straight down because the laser can reflect back and cause damage. We want you to go at an angle like this. Make sure that the laser source is off before changing the tips. And here's the cutting tip. We'll try this thin piece first, and this is 1mm. All right, let's see what happened here. I definitely burned off some paint. You saw all the smoke. You'll want to do this in a well-ventilated area, but it's pretty precise. I'm gonna say really more precise than a plasma cutter. You see, I didn't get through all the way right here, nor was I very straight. But there's the edge, pretty clean. One important thing to keep in mind when you're cutting is that once the laser cuts through the metal, it's going to be focused on whatever is beneath that metal, which is why I put this thick piece of steel beneath it. See, I had that clamped to the bench vise. Once I cut through that first piece of steel, who knows what I will be burning behind it in the background. So will the cutting laser damage things in the background as the beam is dispersed? Let's find out. See, I was cutting up from this high at the bench vise, and I accidentally kept lasering whatever was behind it in the background. Now, because I was so far away, you can see the beam was pretty widespread, about 1.5 inches. But what if I was closer? That was violent. Look how far it burned into the wood. So friendly fire is something you're gonna have to keep in mind when you're cutting with this machine. We'll try this piece next. This is leftover floor panel from the 1980 Toyota, just over 1mm thick, and it's not painted. And let's set up some sort of a guide on this one so I can get a straight cut. And I did make it all the way through in a couple spots. Looks like right here and right there, maybe a little bit right there in the middle, but if I bend it a couple times, it feels like it's gonna snap right off. And here's a look at the cut, and right there is where it didn't go through. You can see it doesn't have the slag hanging down there. Let's see how hot this metal will get. And the warmest point, we are at 295 degrees. And there's the piece I actually cut. It looks like a lot of the heat is just on this thicker piece of steel that I have below it. This piece itself only got up to about 210 degrees. It's actually cooling off right now because it's pretty cold in the garage. This thicker steel here is probably retaining the heat from all the cuts that I've been doing in the same spot. All right, let's do one more cutting test. I got a thicker piece of steel here, 2.5 millimeters thick. I took my time on the first half, and you can see it did go through. I rushed on the second half on the other side, and you can see that did not go all the way through. I don't know if you guys can hear the fans on the X1 Pro. We're kicking up in a high gear on that one. And we built up some heat for sure. Oh yeah, it's even warm up here. So 381 degrees. I guess a lot thicker of steel here is gonna build up a lot more heat. And I didn't get all the way through it again on this side. It was at a bad angle. Let's see if we can bust it apart here. And there's how the cut looks. So the cutting capabilities of the X1 Pro are about on par with what I expected. It's pretty quiet. I was surprised to see that the cut is a little bit finer than that of a plasma cutter. So this laser would be perfect to use with a CNC table. The one thing you need to watch out for, as we discovered, is that once you cut through your material, you're going to be lasering whatever is in the background. I had to open the door because it was getting kind of smoky in here. For the last test, we'll be doing some welding. But first, we're gonna need to set some things up. First, we'll need our tip for welding with wire feeding of our size, which is gonna be the AS12. And here is that. Next, I'll need to reinstall the cable for the wire feeder. So here's my settings: 100% power, 60 Hertz on the frequency, and 2.6 millimeters on the width. This will go all the way up to 5. And this is probably the setting that you'll want to modify and test with the most. The factory setting is 10. I found that I like to go down a little bit. And there's also additional settings that you can do here to have the gas start and end at different times. So gas check, good. Turn on the wire feed, power. Let's weld. I always check beforehand just to make sure my wire is aligned where it should be. Sometimes this thing can get a little bit loose and get knocked to the left or the right. Wire is stuck on here. There's probably a setting that I can do to make this better. This always seems to happen here. Also, I forgot to check, I had it on pulse mode. But there's what the weld looks like, pretty good until the end. I'm more of a fan of continuous mode. There's my continuous mode. Again, not great. You see, I'm still kind of learning here. Usually the speed of the wire will just sort of push the gun along as you need, as you just kind of rest it down. You can see that wasn't very steady on this weld, and I'm not sure what happened there. I'm gonna give it another try. So the frequency on this will go all the way from 10 up to 200. Let's try 200. And we'll try some thinner sheet metal as well. Oh, that didn't go well. Let's do 50% power. I'm literally just resting the weight of the gun on the sheet metal. The welder's doing all the work. So once you get the settings dialed in, you could literally do this with your eyes closed and half asleep. Let's try a 5mm swing width, 100 hertz. And you can see I had the gun at the wrong angle at first, and I wasn't even melting the wire. I did start to here, but then it still wasn't melting all the way. My theory is because I'm going twice the width now, 5mm, that power that I had, that 50% power, is spread out more. So I think I need to up the power. We'll go back to 100 here. This is so easy. I think the other side of this, yeah, it is painted. That's what the smoke is from. I'm burning off paint. But look at the third one. So when you go wider, you need to up the power. I really haven't experimented with pulse too much, but let's give it a try. Again, I'm just letting the gun move itself along. We had something going at first, but I think we're trying to go too wide. Again, I'm just resting the gun, and it's moving under its own weight from the wire feeder. This couldn't be any easier. If I could just figure out the settings to get the wire to release at the end, that'd be set. And if you're wondering how hot this gets and how much the heat spreads, there you go. Our max is 200 and it's pretty cold in the garage, so we're already almost 200 degrees. It was probably about 220 as soon as I set down the gun. What happened here is the wire kind of went off to the side and it wasn't in the center of the beam, and you can see that didn't create enough heat to melt it. So once I stopped, lifted, and set it back down so that the wire was in that center of that groove, from there on out, it was smooth sailing until the very end. So I've been doing these adjustments manually, and if you go up here in the corner, there are all kinds of different presets. For example, I'm not sure what all these are, but we have aluminum, carbon steel, there's a stainless steel, and then you have your different thicknesses over here. So let's try a butt weld, and these were just over a millimeter thick. Carbon steel, millimeter thick, check. And that's what it tells me I need to have my settings at. So I'm not getting enough heat to melt the wire at all. Let's give it another try. I'm gonna angle the gun a little bit more this time. And I only got a little bit of penetration. You can see I actually was off a little bit. It wasn't even on the butt. Let's try this side. And it could be that I have a little bit too much of a gap there that I'm trying to fill. It's not big at all. But I've read that these laser welding machines require a little bit more precision than, say, a MIG welder when it comes to filling gaps. We'll go a little heavier on the power this time. Yeah. The wire went off to the side. I think I started to get it a little bit, then I lost it there. You can see the wire didn't melt, and then right at the very end, it worked. I'm gonna go a little bit more wide on the swing width here. And as we learned before, when you go wider on the swing width, you also need to increase the power because you're dispersing that heat over a larger area. Try that. It's not really pushing the gun. Oh, there we go. Maybe I'm just pushing down too hard. I think I was pressing down a little bit too hard. Yeah, that's exactly what I was doing. You can see where it kept stopping right here and building up. I mean, honestly, not a bad looking weld, but these the laser welders are supposed to be a lot more smooth. All right, let's do one more test. Now that I've got these settings pretty much dialed in, you can see there's minimal gap on these two pieces. Definitely got a little hot at the end there, but that is a smooth weld. And then here's how the back looks. Let's see how strong it is. It's just starting to crack right there. And the way in which this broke, looks like I had a lot more penetration on the left piece and hardly any on the right piece. As you can see, the weld stuck with the left piece. Let's try some angle iron. And this is almost 4 millimeters thick, 3.7. So let's see, 4 millimeters carbon steel. See what they suggest. 100% power, 32 hertz frequency, and 2 millimeters swing width. And that's now 5 millimeters. I'm just letting the gun do its thing at its own speed here. I'm just supporting it. It's moving under its own speed. So let's see how hot we got on that one. Our temp on this looks like it got to 200 and probably 260, 270 by the time I picked it up because it is kind of cold in here. Definitely more heat on the right side. And how do the welds look? Pretty nice at first, and then okay, and then meh. I think what happened was the piece might have spread apart a little bit toward the end there. See that gap? And here's what the back looks like. Yeah, when I first started off, you can see I wasn't actually getting all the way through. And then about halfway, I guess once the pieces might have spread from the heat, then the wire started to go all the way through. How strong is it? And you can see I did not have a lot of penetration joining these two pieces together. You know, this isn't quite as simple as MIG welding where you have your power and your wire speed. You have, you know, nearly infinite parameters to try and choose from. Then you have your wire speed adjustments, and then you've got your gas and your fall time, your rise time. A lot of the videos I see make laser welding look like it's a lot easier than it is. Let's try one more butt weld on these two 1 millimeter pieces. These are the ones that I cleaned earlier. So carbon steel, 1 millimeter, 80%, 80 hertz, 3 millimeter swing, 10 millimeter wire speed. All right, I think I'm finally getting somewhere. This looks beautiful. So starting is kind of tough because you can't tell if your wire is right in the center, and as you can see, it was not. But once I got that wire centered in the butt, it is the smoothest weld I've made in my life. And here's how the back looks. This was gonna be the last one, but since I finally got a nice weld, I'm gonna go try the pulsed again here. So the auto preset settings were spot on for that. And we'll try these as well. No, try again. Point it down a little bit more. Still no luck with the pulsed. I should have quit while I was ahead. It looks like it's just not getting hot enough. So let's try more power. 100. All right, I think I have redeemed myself somewhat at the pulse mode. It still doesn't look like I got a lot of penetration there. Not much at all. So you can see my continuous weld was only on the very, very top edge of this butt joint. And same with the pulsed. So while the cleaning and the cutting were pretty much straightforward, you saw the welding was a little bit of a learning curve. However, once you get the settings dialed in and you get the method down right, you can produce some extremely clean welds. Now, I've never TIG welded, but I'm told it's rather difficult to learn, and this could be more of a simple alternative to being able to weld all different types of materials such as aluminum and stainless without the learning curve of a TIG. And while it's great for sheet metal, I don't think I'd use this particular X1 Pro for anything structural, say like making custom engine mounts. This model just doesn't have the power needed for that penetration. One thing I did discover is that your joints need to be pretty precise and even when you're using a laser welder. A lot of the work I do, say replacing floor pans or rusty rocker panels, rusty body panels, etc. As I'm cutting these panels out and fitting in the replacements, my joints are not that precise. You know, there's a lot of variation there. And it's easy to add material as you go with the MIG welder. With the laser welder, the process is very linear and you're pretty much doing the same bead from start to finish. One feature that I do want to try out once I can improve my skills a little bit is this machine can weld underwater. So that's kind of cool. Another nice thing is that you don't need to use the heavy gloves and the welding masks that you need with traditional welding. All you need are the shades and just a pair of light work gloves. I already mentioned earlier that I love the design of the machine, but I really like the user interface. I like the touch screen, I like the menus, I like how everything is laid out, and I really like the monitoring system where you can see every aspect of the machine to see if everything is operational. I also like that you don't have to use shielding gas the whole time. You can save some money on gas and just use compressed air for the cutting and the cleaning. And being a 3-in-1 machine, this could replace 3 separate machines, a laser welder, a laser cutter, and a laser cleaner. Although the laser cleaning mode max width of 8 millimeters is going to take a lot more time than a dedicated laser cleaning machine, but as we saw, it does do the job even on heavy rust. And the X1 Pro costs less than just buying one of those machines individually. There's a couple things that I wasn't a big fan of. For one, all the cables and wires, especially like the little ground clamp wire, everything just kept getting tangled up over time. I had to go back and kind of unwind them. I have a pretty small workspace, but if you had a large welding table, it'd work a lot better to have everything all spread out. Another issue I had was with the wire feed cable. Sometimes it would get knocked off to the side or pushed a little bit and it wouldn't be perfectly aligned with the tip and it wouldn't melt the wire. So that's something you got to keep an eye out for. I only had one issue with the build quality of the machine, and that's the push gas line on the back of the unit. If the line isn't perfectly centered, if it sort of gets pushed off to one side or the other, it will leak gas from that fitting. It's also important to keep in mind that this machine will require some maintenance over time, as all laser machines do. There's protective lenses and focus lenses, And if you stay up on the protective lenses and keep those replaced as they start to degrade, then your focus lens will stay okay. And it's not hard to replace a simple protective lens, but those are consumable items and they will need replaced over time. It would be nice to have the option to buy like a canvas or a cloth cover to put over the X1 Pro when it's not in use, just so all the dirt and dust in your garage or your shop doesn't end up on the unit. Maybe put a few compartments on the sides of the cover to store things like the gun and the tips and the lenses and everything else. But that's my 2 cents, and I'm going to keep on practicing using the laser welder and get better at it, and I'll check back in. Thanks for watching.